Welcome to Cloud Coffee and Certs, the podcast where we chat about cloud certifications, learning cloud skills, and staying confident on the tech journey. Grab your coffee, relax, and let's level up together.
Hey everyone, welcome to another episode, another week of exciting topic around AWS network security and specialty. And of course, another exciting news because, well, things are happening really bad fast. And hey everyone, welcome to another episode and another week of exciting topics around AWS networking, security around networking, and of course another topic or news which is impacting maybe any organization or multiple organizations. And I have another exciting news this week, and this time it's around AI, because why not put AI into everything? If you are putting AI into your solutioning, you're putting your AI solutions into day-to-day work of management, developers, junior engineers, or maybe senior management. I mean, AI should be having some sort of security risk in itself as well, right? So that news which I'm covering today is around that as well. And of course, we will be continuing topic of Route 53. We last time started it, but I want to cover more around that because, of course, Route 53 is a DNS service which is provided by AWS. Because of DNS in itself, the criticality and importance of DNS in any network, AWS managed DNS service, which is Route 53, comes with its own features, its own use cases, and design pattern, which is specifically required for this certification. So I will be finishing Route 53 off today with different scenarios, design patterns, and of course use cases. We will try to see if we can get some glimpse of next week episode's topic as well. If not, then absolutely fine. I mean, we have enough time to cover all our certification topics of AWS networking specialty examination. So after this short break, we will be starting off the news.
Let's hit pause on everything else for a moment and look at what's changing in the world of cloud and security lately.
All right, welcome back. Now, in this week's news, I am going to tell you guys a story that involves Roblox cheat code, which is a productivity AI tool, and data breach around that, which is actually being sold for $2 million. It sounds like a bit stretch, but every link, every scenario in this is real, and it just happened like pretty recently, maybe a week or two back. And who was the target? Of course, if there's a cheat code, if there's a vulnerability, and if there's a scenario where an organization is being exploited, we of course have some target as well. In this case, the target was Vercel, which is one of the most widely used cloud deployment platforms on the internet and the company behind Next.js framework. So it's not like something smaller organization. It's a pretty big name. And let's break it down. So what happened? I mean, let's start with the target itself. Now, I mentioned that Vercel is a pretty renowned company, and they use cloud infrastructure a lot. And uh, because of that, their developer deploy web applications at scale. So they are kind of like a SaaS product, if I say. And of course, because of this immense product base they have a lot of customers as well. Now everything was going smooth and fine, but last week they published a security bulletin confirming that an attacker had gained unauthorized access to certain internal systems, and criticality is limited to a subset of customer credentials which have been compromised. And attacker is described as highly sophisticated with deep operational knowledge. So this is something which Vercel is claiming. Now, of course, they won't be saying that this is a rookie attack. So as per them, they are pretty secure, but somehow still being breached. So the attacker is really having some good knowledge of what they are doing. And this is a simple case of a supply chain attack, which means the attacker didn't break directly into the Vercel. So they have found a door which was already open in a tool that Vercel trusted. Now let's rewind further and see how it started. So according to cybersecurity firm Hudson Rock, the whole chain begins when an employee at a company called Context AI, which is a small AI productivity startup. So this employee actually, sometime around Feb, was browsing for Roblox game scripts, cheat codes, and one of those scripts was actually laced with something called Luma Stiller, a well-known piece of InfoStiller malware. So once executed, this script quietly harvested the employee's credential, their API keys and whatnot, and of course a support account at Context AI itself. Now here's where Context AI sort of became a pivot point for this whole attack on Vercel. So Contact AI, because they make a AI productivity tool, their agents help you build presentations, manage documents. One of their product is called AI Office Suite, and to use it, users connect it to their Google account. A Vercel employee who had signed up for this AI Office Suite, not through an enterprise agreement, just as an individual customer, using their corporate Vercel email address, and then when they are connected, they clicked allow all on the permission screen. And that allow all click handed the app broad access to Vercel's Google Workspace environment. Now, not just the employee's personal files, it means all configuration at Vercel was allowed by this single grant to propagate enterprise-wide. So by March 2026, when the attacker armed with his stolen Context AI support credentials, accessed the Context AWS environment and harvested OAuth tokens for consumer users, and one of those tokens belonged to Vercel employee. So in short, it was not directly that someone attacked Vercel. They actually had attacked a small AI organization, and because one of the Vercel employee was trying to access or use that AI suite, they actually in indirectly handed over their own access of Vercel organization to this tool and in turn to the attacker. So it was not a 0 day, it was not something called like sophisticated exploit or malware. It was just over permission granting and supply chain that nobody was watching closely enough. So, of course, Vercel moved quickly, and once they identified the breach, they engaged Google's services, Google's Mendian service. There was incident response plan as well, and they of course coordinated with GitHub, Microsoft, and all the other security firms. In short, they did whatever they can from their part to make sure that everyone is aware. They also published a list of recommended actions, a reviewing of activity logs, rotation of environment credentials to all their customers, because ultimately you don't want it to be something bigger, so it not impacting all the customers of Vercel. So this story is actually really dramatic. I mean, Vercel in a way is not something which was expecting like this thing to happen, so they might have closed all the doors from their side, but somehow because of over emphasis of organizations to use AI tools these days, one of the employees did nothing wrong. I mean they did something wrong, but in a way they did nothing wrong by trying to use AI as much as they can in their day-to-day work for improving their performance and saving the time. So like I said, no exploitation, no 0 day, but just an unsanctioned AI tool, and that's it was enough for attacking this organization. Well, the Vercel breach is a case study in what happens when AI tool adoption outpaces the governance. So the fix isn't like stopping using AI tools. I mean, uh, you know that that ship is already sailed. You want employees, you want organizations to embrace the AI tool culture, adoption of AI, but the fix is to treat them like a privileged access they are. So don't grant full access to AI tools for your whole infrastructure. If you are using keys, saving anywhere, rotate them frequently, audit what sort of grant permissions your keys or your, if in this case like OAuth configuration, what sort of permissions they have. And of course, don't download something in your laptop, or don't subscribe or don't install any software if it's not approved from your organization IT. And if even if it's approved, then you make sure that you are getting it from your internal IT's official Artifactory or repository. So don't just download it from anywhere. Make sure that your organization software portal have that software. And if your organization doesn't have software portal at all, then of course that's a big gap as well. So you can, if you're working in an IT organization and if your organization doesn't have software portals, then of course you can recommend that please have an internal software repository from where you are allowed to only download the official versions of any software. Well, that was it. I mean, another use case of embracing or installing using a software which is not allowed as per your organization, but you ended up using it, and of course it led to something which no employee want to have. Like, no one wants to be the one which caused this sort of attack or this sort of impact on their organization, right? So that was it for the news of this week, and I hope we have learned something from that. And before we move into our main episode, let's take a short, quick break.
Let's level up, refill coffees, and dive into the main episode.
All right, welcome back. So we are continuing our DNS journey, which is by Amazon Route 53, which is managed services by AWS. We have already covered what DNS is. So we by now know what's the role of a DNS, what's the role of Route 53. And one more thing we did last week was what are different type of records which we can have in a DNS. So we can have A records or CNAME, MX record, TXT records. So we have understood all of them about. We tried to cover all of them in the last week episode. Now, in this episode, we will be starting with something which is called DNS zones. DNS zones are nothing but sort of place where you are creating your configuration. So now, if you want your DNS to hold a domain which need to be accessible from public internet, then you have to create something called public hosted zone. And for example, if I have technocoffee.com, then technocoffee.com, I want everyone in the whole wide world to reach and able to access this website. So it doesn't make sense that I create this website in a private zone. So what I'll do is I'll create this website as part of a public hosted zone. So that's what hosted zone concept is. So it is sort of like a container that hold DNS records for a specific domain. And if you want your domain to be reachable from internet, then you have to create something which is called public hosted zone. Of course, we don't all have a scenario where our domain should be reachable on internet. For example, if you have a subdomain, or even if you have sort of like a main domain which is part of your organization, which is set up internally to be accessible only within your office internet. So you don't want that to be reachable from external internet, but only your organization's intranet or private network should be able to reach that domain. In this case, there is no point of creating a public hosted zone, so we can create something which is called private hosted zones, which makes your domain to be reachable only when you're inside AWS network. So what that means is your domain or your hosted zone is tied directly to your virtual private cloud VPCs, and only when you are inside that VPC. So for example, if you are trying to access the domain using a virtual machine EC2, which is part of that VPC, it will be able to resolve, it will be able to use that domain. That domain won't be able to use, or you won't be able to use that domain from outside the AWS network. So that's the point of having private hosted zone. It's a really powerful concept, especially in the case where you want to make sure that all traffic remain private. You are not hosting your private applications which are outside. You don't want your anyone outside your organization to reach. You can create those domain as part of this private hosted zone, and you have to associate VPCs to this zone. So your VPCs, if you have like multi-region, multi-account scenario as well, you can still reuse the same concept. So it's not something like you are tied to a specific VPC and you have to create new hosted zone for each VPC. Like I said, it's a powerful concept. You create one and then you associate different VPCs with this private hosted zone. So if you have 10 VPCs, then you can of course use this private hosted zone by associating with them. How can someone from on-prem be able to reach this domain? Because like I said, it's something which we want to keep the traffic inside your organization. So your organization might be having few services which are running on-prem. In that case, we have something called resolvers, which is nothing but a kind of forwarder, if you're familiar with the concept of forwarder. So these forwarders will create VPC endpoints, which will be then acting as sort of point where your request to DNS from on-prem might be received. So if you have your on-prem application which you want to be connected to a private hosted zone on AWS, you can create something called inbound resolver, which is responsible for inbound request coming from everywhere, be it your on-prem, be it your Azure environment. So from different multi-cloud environments, you can send inbound requests to your private hosted zone. We also have a concept of outbound resolvers where application or your EC2 resources or any other resource, to be honest, can send a request for your on-prem domain. So if you have maybe on-prem Active Directory, which is having its own domain and you want your application to reach to that domain, then you can use something which is called outbound resolver, which is nothing but creating a VPC endpoint which will forward any request from your resource to the on-prem DNS. So that's called the concept of outbound resolvers. Again, really powerful concept, and together they make sure that we are using a private network and creating sort of like hybrid multi-cloud scenario. Now let's talk about something that often causes confusion, which is TTL or time to live. It defines how long DNS responses are cached. So if I say in simple terms, TTL controls how long other systems remember your DNS server. So if, for example, if your TTL is 300 seconds, that means other DNS resolvers will cache your records for 5 minutes. During that time, they won't be asking or sending a DNS request again. And why it matters? Because it directly impact the performance and costing as well. So if I break it down, if your TTL is low, like maybe 60 seconds, that means changes propagate quickly. Your record will be cached only for 60 seconds, and after 60 seconds, any new request will be going to your DNS. So it will help in testing infrastructure if you're migrating server. But it also means that you have more DNS queries, more DNS requests will be coming to Route 53, and it's directly tied to higher cost as well because now you're sending more requests to your DNS. On the other hand, if you have really high time to live, I don't know, maybe in hours, so that means your cache will be longer. So you have fewer DNS queries, you have lower cost, but it also means that if you have, for example, a new DNS change, it will not be propagated quickly to your endpoint system. So your endpoint, because they are still caching the local record, they won't be sending request for new A record. If you have some configuration changes on DNS, they won't be applied as quickly as you really wish to. So that's why TTL is again powerful concept. And another concept around DNS is DNSSEC, which is securing DNS, which ensure that DNS responses are authentic and they haven't been tampered with. How does it work? Well, DNSSEC adds cryptographic signatures to DNS records. So when a resolver receives the response, if your end system receives a response, it first verifies the signature. And if the signature is matched, the response is trusted. If not, the response is rejected. So it helps in protecting maybe man in the middle attacks or DNS spoofing, which is really important and really one of the key concepts being discussed, especially in the cloud world. You don't want any attacker to create fake DNS records and then you as an end user thinking that you are actually been getting response from a correct domain, but actually you are getting it from a domain which is set up by an attacker. If you are sending the request to a genuine domain, only then, because of DNSSEC, you will get the response. You can verify it. If not, then of course your verification will fail and you won't be able to use that domain. So you are safe from using attacker's domain. So it's pretty amazing. I mean, if you think from that perspective. So DNS is not just a concept where you resolve everything. It's more than that. You can add more security concepts around the DNS resolution as well. Now let's discuss some of the design patterns. We have already discussed about resolver endpoints, which is really powerful concept in terms of hybrid and AWS architecture using inbound and outbound resolvers. So that's one of the design pattern which you can use as part of creating a hybrid architecture in your AWS environment. We also have something which is called global traffic management. So you can actually use Route 53 to to send traffic to a specific backend, maybe EC2. And this is called something which is global traffic management. So you don't have to create load balancer for everything. Route 53 provide a simple failover service mechanism in itself as well, which is created as part of routing policies. Let's discuss something around that as well. The Route 53 provide couple of them. One is called simple routing, in which you create one record with multiple values, so multiple IPs, and the client is picked randomly without any health check, without any intelligence. So it's great for testing environment. We also have something called weighted routing, where you can associate it weight with each record, and Route 53 will distribute the traffic proportionally. So a weight of 100 and a weight of 200 means one third of traffic goes to first target and two third of will go to the second target. So this is again really fantastic if you are having sort of like a Bruggen deployment, or if you are rolling out new changes, you can gradually shift traffic from your old deployment to the new deployment just by changing the records on the DNS itself. So like I said, you don't need load balancer for everything. You can do these small failover changes or small routing policies on the DNS itself. Another interesting concept is around geolocation routing, where you can route the traffic based on maybe continent or country or the originating state. So this is really useful when you have some sort of like data residency requirements. So if you are having a European users who must be served with infrastructure in EU, then you can create some sort of DNS records in which you specify that any request originating from a specific country's IP address should be sent to a particular EC2, should be resolved by DNS to a particular EC2 IP. So the traffic originating from a specific country should be only handled by EC2, which is set up only for that particular country as well. So this is a really important concept in terms of geolocation. We also have something called failover routing, which relies on Route 53 health checks. Now, Route 53 health checks are nothing but just a monitoring kind of service. So if health check fails, then traffic will automatically shift to the secondary IP. So it's sort of the foundation of a disaster recovery strategy. Now, health check in itself have multiple ways. So your Route 53 health checks can monitor an endpoint, which can be IP or domain, over HTTP, HTTPS, or TCP. They can check for a specific string in the response body as well. So if you have something like slash index.html, it will check for that response. And if it's that particular string is matched, only then the traffic will be allowed. Otherwise, it will be dropped because you will be failing on health check. They can be calculated. You can combine multiple health checks as well. So you can have sort of like and or logic to build sort of consolidated health checks as well. So all these scenarios, all these services around geolocation, latency based routing, and health checks, they cover and help us using Route 53 for global traffic management. So, like I said, you don't need any additional service to cover these simple use cases. Route 53, as an its own service, is able to provide this use case as well. Another thing is domain registration, which is nothing but if you are owning a domain and you want to make sure that it's registered to your organization. So if you are buying a new website, a new domain for your website, then you can use this domain registration feature from Route 53, which is sort of like foundation of setting up a new organization. And this of course help in creating your zone for your domain, which is also registered to your organization. So Route 53, like I said, it's not just a DNS service. It have a lot of use cases, and one of them is domain registration. That means you can register new domain names directly in AWS, which is convenient because you have every configuration in one roof. And of course, you have a single bill as well. So you can also transfer your existing domain from other registrars. Now, when we register a domain through Route 53, we get a hosted zone for my domain by default, and it will have all the baseline configurations as well, which then I can further use if I want to, for example, create or use this domain service for mail server, then I can create MX record. If I want to use this domain for my applications, then I can use era codes which are associated with EC2 IP addresses. So I can do all those sort of things in my this public hosted zone, which is created automatically when I register my own domain using AWS. It also enable auto renewal as well, so you don't have to keep on renewing it. AWS can do it on your behalf as well. In terms of what top level domain you can use, so top level domain is something called, like for example, .com or .co.uk. They are top level domains, and AWS have a whole list of top level domains as well. So it's not like because it's provided by AWS, this service will not have all the features which you can get if you are getting it from any other registrar. So if you are registering your domain, if you are buying a new domain from AWS Route 53, you can have same level of range or same level of options which you can use to buy your domain. So it's something which is really incredible if you want a straightforward sort of configuration. You don't want to hover or don't want to rely on multiple organization or multiple services. AWS Route 53 can do everything for you on your behalf. So that's all in terms of different design patterns of using AWS. So we can use AWS Route 53 in a hybrid environment using inbound and outbound resolvers. We can have private and public hosted zones. We can register our domains. We can have global traffic management as well by using different routing policies and health checks, which let me send my traffic to different endpoints using the Route 53 itself. So I don't have to set up a more advanced load balancer use case for this simple failover routing between my different EC2s or different endpoints. The Route 53 in itself is one of the most incredible service I used in AWS, and it's really important in terms of making sure that you are registering your domains, keeping your domains locally, and you are using them as part of your application registration, as part of your application domain name resolutions as well. All right, that's it for this week's episode. Now, in next week episode, we will be covering something called design patterns around load balancing. So we have covered load balancing before as well, but this will be a more detailed discussion on different load balancers, how different load balancers work, what sort of different design patterns AWS have from their load balancing services. So this is something which is coming up in the next week episode. New episodes are coming hard and fast, so make sure you are buckled up, make sure you are learning as we go, because our certification exam is also not that far now, because my certification date which I registered for is next month end. So it's only 1 month before I'll be sitting for my AWS networking specialty certification exam. So I'm not stopping now. I will be making sure that I learn more and more about this AWS networking concept and share with you guys as much as I can. Alright, that's it for this week's episode. Let's catch up next week. Goodbye and good luck.
Been listening to Cloud, Coffee and Certs. Thanks for tuning in. Don't forget to follow and share if you enjoyed this episode. Until next time, keep learning and keep growing.